In this video, we're going to talk about Charles' law, which is the second of the three laws that are part of the combined gas law. And Charles' law is a relationship between temperature and volume. And so we have V1 over T1 equals V2 over T2. And unlike Boyle's law, which we saw in a previous video, Charles' law is what's known as a direct relationship. And so when one goes up, the other goes up. And they go up in incremental amounts. So for example, if I have a volume and I double my volume, then I'm going to double my temperature. If I have a volume and I'm going to cut it in half, then my temperature is going to cut in half as well. So they're going to be the same value and same proportion, because anytime you have something like this, it's kind of like 2 over 4 is the same as, 4 over 8. Because the fraction is going to be the same. And so this is a direct relationship, where the other formula, when we did Boyle's law, it was P1, V1, P2, V2, it was linear. And this, if you look at this, this is more, cross multiply and divide. Right off the bat, it looks a little different. And so this is going to be a direct relationship. So let's take a look at a couple of these. And one of the things we have to consider that we saw in a previous video with the formula for changing Kelvin into Celsius and Celsius into Kelvin is that anytime we do gas laws, it's crucial that we use Kelvin temperatures. Because if we look at this first question, for example, if the temperature of a gas is 0 degrees and the temperature is changed so that the gas volume doubles, what is the new temperature of the gas? Well, if I were to volume, I don't know what the volume is, but if I were to double it, how do I double 0? I'm not really sure how you can double 0 mathematically and still not get 0. However, if we change it and if we use K equals degrees C plus 273, then we're going to be able to incorporate the correct temperatures. And so if I substitute 0 into this formula, then K is going to equal to 273. So my temperature to start is 273 K. And it says if the temperature of a gas is 0 degrees and the temperature is changed so that the gas volume doubles. So if volume doubles, then we know temperature doubles. So if the original temperature was 273 and we know it doubles, I'm just going to multiply this by 2 and get 546 K. Okay, 546 K, because if volume doubles, then temperature doubles. Let's take a look at a couple more examples here with this law to make sure that it's clear for you. So a gas has a volume of 10 meters cubed at standard temperature 273 K. What will the volume of the gas occupied if the Kelvin temperature is doubled? Again, if one gets doubled, they both get doubled. So if I double the temperature, I'm going to double the volume. So if I start out with 10, I'm going to go to 20.0 meters cubed. I've doubled the volume. If the temperature is reduced to 1/4, if I cut my volume or my temperature in half, the other one gets cut in half. So if I cut one by 1/4, the other one gets cut by 1/4. So really it's 10 divided by 4, okay, a ratio of 10 over 4, which is equal to 2.5 meters cubed, okay, because it's 1/4 of that original value, because it's proportional. Let's do another one here. Suppose 500 milliliters of oxygen is collected at 25 degrees Celsius. What will the volume be if the temperature is increased to 50? So here's the thing, and one of the reasons why we have to do conversions to Kelvin. And so if we just look at those two values, to go from 25 to 50 is really multiplying by 2. But when we look at the math difference, that's a change in 25 degrees. Going from 25 to 50 is a change in 25 degrees, right? But when we look at the Kelvin temperature, we have to substitute Kelvin temperatures. So if I add, again, 273, which we see up there, Kelvin equals C plus 273. If I add 25 plus 273, we get 298 K for 25. And if I add 50, I get 323 K. Now, if we take those two numbers, 298 and 323, both of them, again, that's a jump of 25 degrees. That's fine, but that's not an increase of twice. That's not twice as much. Okay, is this, question mark, is that twice as much? No, it is not. So that's the big difference with Kelvin and Celsius. a doubling of Kelvin is not a doubling of, a doubling in Celsius is not the same as a doubling in Kelvin and vice versa. So we need to make sure that we are in the correct units, which in this case is going to be Kelvin. And when we set it up, again, 500 milliliters is collected at 298. What will the new volume be if the temperature is increased to 323? So now we got to plug it into our formula, which we see here, V1T1 equals V2 over T2. So when we set it up, we have 500 milliliters was originally at 298 K, and I'm going to set that equal. We want to know what will the volume be, so V2 when it is 323 K. So now I have basically a cross multiply and divide and solution here. Fortunately, in this case, the thing I'm trying to solve is in my numerator. So really, I just got to multiply this side by 323K and then multiply over here by 323K. Oops. Make sure it fits in. So notice I can cancel out my 323s on the right side and I'm left with V2. And on the left side, I brought over and multiplied by 323. My K cancels out, and so I'm going to be left with my unit of milliliters, which is what we want. Now it just becomes a simple plugging it into your calculator. 323 times 500 divided by 298. In this case, V2 equals 542. Now if we go back and look at the math, my unit milliliter, notice I didn't double. I went from a 500 milliliters to 542 milliliters. That's not a doubling because the temperature technically did not double. 25 to 50 sounds like a doubling, but in reality 298 to 323 is not a doubling of temperature, and therefore I should not see a doubling of volume. But it did increase. That's one thing you can look at. Temperature went up from 298 to 323, so if temperature goes up, volume should go up. Temperature went up a little bit, volume went up a little bit, from 500 to 542. So again, Charles' law is a law where temperature and volume are directly related. When one goes up, the other goes up. Hopefully you found some value in these explanations. If you have any questions or comments, please leave them below, and we look forward to seeing your success in the chemistry class in the future.